Okay, so today I want to talk about arc length. If we had a curved arc like this and we wanted to find the length of it, we could use the distance formula to break this up like 1, 2, 3 and find a distance here, a distance here, a distance here, whatever, 4 or 5. But that's not going to be completely accurate. But luckily we actually have a formula that allows us to find arc lengths using integration. So the function y of f of x is differentiable, over the interval a to b. The length L is the integral from a to b of the square root of 1 plus f prime of x quantity squared dx. So, and also you could do it the other way with dy from c to d. So let's actually do a few problems. We're asked to find the length of the curve f of x equals 4 halves x to the 3 halves minus 1. This is just an x here. Over the interval 0 to negative 1. Well, f prime is going to be 2 radical 2x after I do all these calculations. So the length of my arc is going to be the integral from 0 to 1 of the square root of 1 plus 2 radical 2x quantity squared. If I square that, I get 1 plus 8x. I can use u substitution, so I'll get 1/8 from 0 to, I guess, 9, because I changed my bounds here from 0 to 1 and 1 to 9. So this should be a 1. I said 0, but it should be a 1. So it's 1/12. You can calculate. We get 13/6. So the length of this curve here over this interval from 0 to 1 is 13/6. Let's do another one. We're asked to find the length of the curve of y equals 2/3 x squared plus 1 to the 3 halves from 0 to 3. Well, first I have to find my integral. Don't forget that you also have to multiply by 2x. So once I simplify, I end up getting 2x times the square root of x squared plus 1. I integrate from 0 to 3 of this quantity squared is going to be 4x squared times x squared plus 1. I can rewrite this, and then if I factor that, I end up getting 2x squared plus 1, quantity squared. I take the square root. I can just integrate this as normal, evaluate from 0 to 3, and I end up getting 21. So the length of this arc is 21 from point 0 to point 3. What if I want to find the length of the curve y equals 2/3 x squared from 1 to 8? Well, I know that y prime is equal to 4/9 x to the negative 1/3. And in this case, I'm actually going to use my calculator. So I'll put it over here. I'm going to do math 9. So I'm going from 1 to 8 using the square root of 1 plus 4/9 x to the negative 1/3 quantity squared, and that's all in regards to dx. And if I calculate this, I get the arc length is 7.28937. Don't forget you need to use at least 3 decimal places. All right. Finally, we're asked to find the length of the curve x equals y cubed over 6 plus 1 over 2y between 2 and 3y. So x prime is 1/2 y squared, which is minus 1/2 y to the negative 2. Okay? So if I rewrite this from 2 to 3, I square it. I end up getting this. I get a common denominator. I get this. I do some factoring here. Finally, once I take my square root, I get y to the 4th plus 1 over 2y squared. I can break that up so that once I finally evaluate it, I end up getting, and I put this in the calculator, this is an equal sign, I end up getting 3.25. Not actually a complicated problem. It looks pretty messy, but it works out pretty well. So that's arc length. Hopefully that helped make sense for you. If you have questions, you can leave them in the comments, and I look forward to seeing you in class. Bye!